Hello everyone, so welcome back to my channel and let's start with today's Leetcode challenge. Apologies for uploading the video so late. So till now we have completed 3 challenges. In case you have missed any, you can watch it on my YouTube channel. I've created a curated playlist for the same, and meanwhile I will also be completing that Leetcode 75. In case you have missed any question from that, you can watch it same on my YouTube channel with the playlist Leetcode 75. So let's just start the today's question quickly. Okay, so there's a party where n friends numbered from 0 to n minus 1 are attending. There's an infinite number of chairs in this party that are numbered from 0 to infinity. When a friend arrives at the party, they sit on the unoccupied chair with the smallest number. Okay, so for example, if chairs 0, 1 and 5 are occupied, when a friend comes, they will sit on the chair number 2 because 0 is occupied, 1 is occupied. So 2 is the least number that is unoccupied. When a friend leaves the party, the chair becomes unoccupied at the moment they leave. If another friend arrives at the same moment, they can sit in that chair. Okay. And we are given a zero index to the integer array times, where times of I contains the arrival of ith friend and leaving of ith friend. Okay. And we have to find the target friend value that on which chair he should sit, and we have to return it. So this is mentioned, return the chair number that the friend number target friend will sit on, and it is also mentioned that all the arrival times are distinct. That is the main thing, right? So we are given this example, so let's just move to the intuition building part quickly. Right, so we have this times and we have this target. So if you see, this is zeroth friend, this is first, and this is second, right? So if you see, this will come at arrival time will be 1 and departure time will be 4. Similarly for this, arrival time is 2 and departure time is 3, and for this, arrival time is 4 and departure time is 6. So when this will come, this is first friend, this will come at 1, right? And it will sit till 4. Okay, now this come at 2, but still this is sitting on 0. Okay, so now when this will come, we have chairs like 0 till infinity. So this is 0, this is 1, right? This is 2, this is 3, this is 4, so on. So if you see, this will come at 1, sit till 4, so we will make it sit on 0. Okay, so let's just have it 0. Now this will come at 2 and sit till 3, so 2 till 3, but this is sitting on 0, so we cannot make him sit on the 0, and then we have to shift him to 1. So this will sit on 1. Now this comes at 4 and sit till 6. If you see, this comes at 4. When at 4, this will be removed. Okay, this will go back home, so this will be free. Okay, at this point, if you see, this will be free, this will also be free because it is sitting from 2 to 3. So when you come to 4 time equals to 4, this will also be go back home, this will also go back home. So this will sit on which chair? No, this does not. This is also free, so he will sit on this because it is mentioned that whenever a friend comes, it will sit on the smallest seat basically, right? So now 4 starting and this is a 6 is the ending time, and you want to return the target is first friend. Okay, first friend is this, and this will sit on which chair that we have found? 1. So the answer is, you see, answer is 1, and this is the given answer in the example. So how we should calculate this? You have this array. Okay, we will take this array, Now what we'll do, we will create a table for the same. So this is a table, right? This is chair 1, this is chair 2, chair 3, and so on. Okay, this is till infinity. Chair 5, chair 6. Okay, so this is till infinity. We just write this d6. Okay, so let's just start with this first. So when this will come, we will have our arrival time 1 and departure time 4. We will check which chair is free. Currently chair 1 is free, right? So we will assign him chair 0. Okay, first chair, basically this is chair 1, so this is chair is numbered from 0 only. So this is 0 1 2 3 4 5, right? Now this will be sitting on 0 chair for till 4 time. Now we will move to here, right? We will check the arrival time will be, now will be 2 and departure time is 3. Okay, if you see the earlier person, so what you should check and keep it here. So the departure time basically we need, because whenever new person comes, he should have to check that the earlier person that was sitting on the same chair, is he is going back home at the time or not. So we will store the earlier temperature that was 4 on the 0th chair. Now you should come to this. The arrival time is 2 and the departure time is 3. So now you will check if your current arrival time is greater than or equal to this, because then only he can sit. If he is leaving and he is coming at the same time, they can sit, or he is coming at later time, then only he can sit. The two conditions, that the earlier time, earlier friend, okay, earlier friend departure time is less than or equal to current friend arrival time. Okay, so we should know this, and we should also have our target that we missed. So our target was 1, so 1 is this only, right? Now we have this arrival 2 and departure is 3, and we have checked that this is sitting till 4. So which chair should be assigned to him? Now chair 1 will be assigned to him, right? And the departure time will be stored here, and our target was 1 only, right? And now we don't have to check for this other persons, because we have found our target first friend and he will be sitting on 1 chair, so we'll just simply return it. You don't have to check for every value in this, because your target was this, you just have to check for him, so you will just return 1. That is your answer. So now what should be like, how should we calculate which data structure should we use? So if you see that these here are 0, numbered from 0, okay, and if you know that in array indexing is 0 based, okay, so we can use this, right? But we have to provide the size of the array. Okay, that is also a question. So what should be the size? If you see that there are, let's just say these are n, okay, and every person has a arrival and departure time that are not, that are basically intersecting. So if you see, this is 1 4, okay, this is 1 4, and the other person is coming this 2 6, let's just say, and the other person is coming at 3 and 7. Okay, they, all of them cannot sit of any chair that is common to them, that this will sit on 0, this will sit on 1, and this will sit on 2. So if you see how many maximum chairs that we need, this is n maximum chairs that we need. So the size of the array, chair array, basically chair array maximum, it should be n. Okay, On maximum n chairs they can sit, right? So that should be our size. Now the question comes that the array that we have times array, it will be like, it can be this, like 310, then will be 15, okay, then it will be 26, and somewhere target should be 0. This is another example. If you see, this arrival time is later and this arrival time is before, so this will come later and this will come before. So you need to somewhere have this sorted based on arrival time, because you need first arrival time, then you need second arrival time, then you need third arrival time, right? So assigning of chair, should that be made optimal, then only if you should do sorting. So first step should be sorting, most important, right? We have to do only we have to do this every time, okay? So sorting is the most important thing. Then second, chair array we need, okay? These things that we need for first approach, okay? These two are required and we will do our operation. Now if you see, our target was 0. 0 was this one, right? 0 was this one. If you do sorting, now your 0 will become this. So what do you need? You basically need what thing you need that can give you an answer. If you see, the answer that you need requires that when this friend comes, on which chair he should sit, and whenever a new friend comes, what we should calculate, that this arrival time of this friend, it should be like greater than or equal to the earlier time of that friend. So when this 3 will come, he will check if the earlier person that was sitting on any chair, if he's leaving on that time or not. So you can keep it target arrival time, right? Since this will be lost, so we can keep target arrival time, that is 3, and we can keep it, and whenever we get it, we will simply return our answer. So let's just do the simple pseudocode for that. We will have chair array of n size, okay, n size chair array, and now we will sort our times array, times dot begin, times dot end, okay. I'm just writing a simple pseudocode. So now what you will do, you will go for each value in that for int I 0 to n. For each value in this times array, you will check first, get arrival time. So times of ith and 0 will give you arrival time, and similarly departure time, times of I and 1. Now you will check for each this chair array, okay. So this is your chair array, right? This is 0, 1, 2, 3, 4. Initially no one is sitting, so we can keep -1 on every one of them, right? So now for each chair you have to check int I 0, I less than n, I plus plus. What you will check? If chair of I is equals to -1, okay. If it is currently empty, then you can basically ask him to sit on this. So what you will do? Chair of I, what will it contain? The departure time, right? And in this here only you will check if your arrival time is equals to the target time that you need. If it is yes, then you will return what you will return, the chair number. The chair number is the indexing, so we will return I. If it is not, we can check here. If it is not -1, then someone was sitting on this chair. What you have to check now? if chair of I that holds the departure time. So this departure time should be less than or equal to the arrival time of someone, right? So you will check if someone is arriving at a time which is greater or equal than current departure time. So then only you can assign him. So again you will do the same thing, chair of I, the next departure time, right? And the same check you can do, right? Also you can do this check here only all together. So we can have, I will write it above only, if this or chair of higher time should be less than or equal to current arrival time, then only you can assign the current chair to the current friend with the departure time, and you will return ith index if the target time is current arrival time, right? So this is a basic pseudocode. And now the time complexity, I will write it. So space complexity, if you see that we are using a n size array, chair array, so space complexity straightforward, big of n, right? Nothing. Now you will see time complexity. This is n log n direct sorting, so big of n log n. Now this is one for loop going till n. Again this is one for loop going till n from 0. So n times n, so it will be big of n square, and if you see the cumulative will be big of n square only. So this is a brute force approach that you can provide in your interview whenever you face this question, because whenever you get a question in an interview, you first try to do it with a simple approach that you can think of. So this is a simple approach that you can think of, right? And now you got this brute force approach, you will write it brute force for understanding. Now interview will surely ask if this n square, if let's just say n was in the range of 0, so 1 till 10 is to power 5. Okay, now if it will surely, n square will surely break, because the maximum time you can get is in the range of 10 is to power 8 or 9. Okay, so this will surely break, and interview will surely ask you to improvise on this n square, and then the improvisation of this will be n log n. Okay, first whenever you give a n square solution, you can improvise on giving n log n. Now how you can use this n log n, right? So first thing that we have discussed, sorting is important, and this we have to do it here also. So now we'll just have our example. So we have discussed that sorting was important. Now we will have our times array. Okay, so it was somewhere like 1 comma 4, then 2 comma 3, then 4 comma 6, and our target was 1. So 1 is this was our target. Now what we have done, sorting, this is already sorted, we don't have to do anything. Okay, now what we'll check, we will go for this, we will have the storage. Okay, so earlier what we are doing, we are using a chair array. Okay, so this is let's just write it optimal approach. Okay, we have this chair array with this zero based indexing. Now what we are doing, earlier all values are assigned to -1, and what we are checking if current chair is available or not. If it is not, then we will assign this chair to the ith person and store its departure time, right? And then we'll move forward and we'll check if this is available or not, and go till all the values. So what all thing we need, if we can store these values directly, this is the chair number and this is the departure time. If we can store this value in somewhere other data structure, that only we think require. And what we have to get from this, that least available chair number, right? This is the thing that we require, least available chair number. So let's just do the try run for this. So we are sitting on the we are on this and friend. The arrival time is 1, departure time is 4, and current chair number, let's just have it 0. So there is no friend in this currently sitting, so we'll assign him 0 with the departure time 0. He will go on 4 time. Now you will move here. Your arrival time is 2, departure time is 3, and current chair number, whenever we assign a chair, we will update the current chair number by 1. You come here. Since your current arrival time is less than this, you cannot sit on the earlier chair, right? Now you will assign him current chair number with the your departure time, this, right? Now comes this friend, right? And so let's just change the target, right? So let's just change the target. Our target was 1 earlier, so we will keep it target 2, right? This was our target. So we have discussed we have to get the target arrival time. Target arrival time is 4. We just have to keep in mind. So now you assign him 1, update the chair number also. Now you come to here 4 6. You will check if your current arrival time is greater than this. Yes, this person will leave at 3 and this will come at 4. You can assign him this chair, right? But you will need a chair with the least number. If this is the least number, you cannot directly say it. So what you will do, this will leave before this, and since you are sorting the array, the other person, let's just have it like you have this 4 6, then 6 and 10, you have also this value. So this is always be greater than smaller than this, so you can directly remove this person because it is leaving earlier him, so he also can sit in the on the same chair. So you will remove this 3 1 and you will free the chair number 1. Now this chair number 1 is free chairs, okay, free chair is 1. Now you will this come this 4, this departure time is 4 and he is also coming at 4. This chair will also be available at 4. So now you will do, you will also remove him because the person sitting on the 0, he will go. Now this will sit on this, right? Because this is the least chair that he can sit on. So you will remove him and you will free it first. First you will free it and you will check if there is another free chair that is least number than this, because you remove this. Now you will remove this and you will add this in a free chair, and now you will check which chair you can assign him, 0 or 1. You will assign him 0. So now 4 and 6 will be assigned 0 chair, and your current chair number was 2 only, you will not update it. Now you will add this here 6 departure time with a 0 because he is currently sitting on the 0 chair who will leave at 6 only. So let's just remove all this and he will be sitting here with the 0 departure time. Now you will come to this indexing, right? This here. But now what you will check, 6, right? The earlier person was sitting on this, so this is greater than this or equal to this, yes. So he will leave at 6 and he is coming at 6. So which chair should be assigned to him? This only. So first what you'll do, you will free this chair, and earlier when you assigned him 0, you have to remove this chair from the free chairs because 1 was only free at that time. Now you will check if this is free, yes, so you will again add it here. Now which chair should be assigned to him will be from the free chairs only, okay. This is a storage to keep what you should add this, what should you keep this in this storage, departure time and occupied chairs, okay. Occupied chairs. So you have stored this here, and the free chair was 10. Which chair should be assigned to him? It should be 0. So now your this will keep, what is it, is 10, and this is 0, right? And your target was, let's just say 4, target arrival time. So you will not come to this. Okay, whenever your target arrival time was 4, you just have to check at that time. So when target arrival time was 4, which share was assigned to him? 0. So you will simply return it 0. And let's just say your target arrival time was 6, right? Target arrival time was 6. Now your target arrival time 6 comes, and which shares you have assigned to him? 0. So you will return 0, right? So you have got your approach. Now which data structure should be assigned, which this will store, or and free chairs will be stored, right? Now you should know that this data structure that we have added, it should be based on this departure time, earlier departure time, that whenever someone was leaving. So if what data structure you should need, we will use another example to better understand it. A small example, right? So times array was this 1 3, then and was coming for 2 5, then someone was coming at 4 and leaving at 7, the other person is coming at 10 and leaving at 12. Okay, and this is 2 4, right? So when this will come, he will be assigned 0. So this will be like 3 will be here and 0 will be assigned to him, and current share will be updated from 0 to 1, right? Now other person is coming, he will check if earlier person is leaving or not. He is not leaving, so which share should be assigned to him? Current share. So he will be added with his departure time 0, sorry 1. Okay, now okay, right, so we will change him to, okay, we will change it to 5, right? That will give us answer. This understanding. So he's leaving at 5, so we will assign departure time because he will leave at 5, right? And first share is assigned to him. Now you come to this part, 4 7. Arrival time is 4, and your target is this only. So target arrival time is 4 only. Arrival time is this, departure time is 7. Now what you will check, if this value, the 4, is like greater than or equal to this, no. But if you see 3, this person will leave at 3 and you can assign him 0 chair, right? This is not going back at 4, but he will go back before 4, so you should assign him the least chair. You cannot assign him because the current chair was 2, sorry. So you can assign him 2, yes, but the least chair that was available at the time will be 0. So somewhere you need to also sort this based on this departure time. So, and this is a dynamic storage, right? Dynamic storage, this is, so what you have to do, basically a dynamic storage with sorting. Now this storage will, what should it be? So the best storage, it should have either set, okay, ordered set, basically not hash set, order set, or in it can be the best that we use, or always priority queue. Okay, this priority queue, so where if you see set the priority to the minimum, so whenever we add this value, so what it will become, 30 will be here and 51 will be here, right? If you see 30 will be here, 51 will be here, and whenever you encounter a new time, so you will check 4 is greater than this, yes, so you should free this first. So you have this your free storage, and you will assign, then the free chair to him, the best free chair, right? The earlier we were discussing that this free chair should also give the minimum value, right? Because when you came to this part, 1 and 0 both are free. So which chair you have assigned him? Okay, so this also should be sorted. Again, what we can use, set or priority queue. So we have discussed that only two data structures that we require. Either we can use an ordered set or a priority queue that will be of type min heap. Okay, in this case min heap, and this ordered set will always be like storing in the non-decreasing form. Now we will do a pseudocode for the same. We have the target this time, right? Target arrival time. So we will have somewhere this value. Now what we'll do, we will have our two priority queues basically, or set, either one we can use. So priority queue. Now this should be of that we have discussed many type. So in C++ we can declare it like this: int, vector int, and greater int. So this is of integer type. This will store our free chairs, and other should what be type priority queue, and we have to store two values that we discussed. Okay, so we can store it in the form of tuple. So this will be a pair of integer and integer type, and similar thing that we have earlier did. Okay, so this is our occupied chairs. See, now we will go for each friend from 0 to n, and what we have to do, we have to first check arrival departure time, that is somewhere, let's just say x or y. We will get it, I will write it directly. So this will be a times of I 0, and this will be of times of I 1. Now what you have to check, we will go for this occupied chairs. If we can have chairs, so what we'll do, we will remove every chair from this occupied chairs and add it in our free chairs. Okay, so we will go while this occupied chairs is not empty, because we cannot remove any empty. Occupied chairs dot empty, and what you have to check, this occupied chair, what will be the top of it. Okay, so let's just say we have this 5, 0 and 4, 1. Okay, so this is sorted, right? Priority queue. Now the other person is coming with 6 time, right? So this is already assigned to him. This is already assigned. This is already assigned. First you will check what thing. So occupied chairs priority queue, the top value, the top will give this tuple, and what you have to check, this first. So this first will be compared. If this first is smaller than equal to the current arrival time. Okay, if yes, what we have to do, we will remove this, and this free chair will be added to other free chairs, right? And this is occupied chairs. So first check will be this, and now what we do, we will store free chair, that is occupied dot top dot second, right? This is store. Now we will do occupied dot pop. We will remove this, and this free chair will be added into this free chair dot push the current chair, that is this FC. Okay, so we have done this. Now what we have to check, when we come out of this loop, all the values that are all the departure time that are smaller than this will be removed and the free chairs will be added. Similarly, this will be added. So in this we have 1 and 0, okay, in a sorted order, non-decreasing. Now we'll check if let's just say nothing is removed from this, what chair should be assigned to him. If this is coming, let's just say example is the coming time is 6 only, and in this we have 7 with 0. So if you see 7 with 0, right, now you cannot remove this. So, and there is no free chair, okay. So what you will assign it to him, 6 is the arrival time, and let's just say 10 was the time that he is going back. So 10 with the 1, and this one is coming from the chair, current chair that we are having. So we'll check if free chairs is empty, right? If the free chairs are empty, that means there are no currently free chair. So next chair we should assign it to him. So occupied dot push, what is should be added, the current departure time with the current chair number, okay. So what you should check directly here, if your current arrival time is equals to target arrival time that you have, target arrival time, if yes, then you should return the current chair number that you are having, current chair. If it is not, then you should update the current chair. This should be returned before the updation of current chair, because you have to give the right answer, right? Now your free chair is not empty. Now what you will do, you have to first also assigning or also returning, both things you have to do. So occupied, what you have to push in this occupied, the departure time of the current friend, and this free chair dot top, right, because this will be containing the smallest chair that is free, right. And you have to check again same thing, if arrival time is equals to target arrival time, then you can basically return this top, or you just have to do free chairs dot pop, because the current chair is assigned to him. Now you don't have this free chair, so you will remove. So if you see directly, if nothing happens, you will return -1 out of this every loop, okay. So you will write this beyond this for loop, this while. And if you see directly the time complexity, what is the time complexity? If you see that we have done the sorting, so that is n log n, okay. N log n is a sorting part. Now if you see, this is going for n, okay. So big of n. Now yes, if you now see these operations on the priority queue that we are doing, okay, every operation on priority queue takes time of big of n log n, right. So the maximum time complexity you will get here is big of n log n, and similarly the space complexity part, that is big of n only, because we are using two priority queues, okay, that will store our current chairs, occupied and free chairs. So if maximum in this, that all the chairs have been occupied and your target was also at the last, so maximum it can store the n chairs, right. And in the free chair part also, if every chair is free and you have used every chair, so it will maximum store n chairs. So the maximum time space complexity will be big of n, right. So I think we are mostly good on the approach part. Now we will move to the coding part to better understand it, right. So let's just start the coding part, okay. So first we will store the size of this times array, so this time size, right. Now what we have to do, we will store our target friend arrival time. So target arrival time will be stored in this times, then target friend, and 0 will be given, okay. And also we have to create a chair array, so it will be chairs will be of n size and -1 will be assigned to all the chairs. Now what we have to do? We have to do the sorting. So times dot begin and times dot end. Right, now we have done the sorting, and we have to do now, we will go for each friend for 0 to n. The current arrival time of a friend will be times of I 0, and similarly we will get our departure time. So it will be departure time, so it will be this. Now we have got the arrival time and departure time. We will go for each chair. Now what we have to do? Either if current chair is not assigned, right? Not assigned. If equals to -1, then what we have to do? We have to assign the current chair to the current person. So chairs, so it will be chairs of I, but it will store the departure time. And here only we have to check if the arrival time is equals to the target arrival time. If yes, then we have to return the ith chair. This is not, then what we have to check if the chairs of I, but it will check the, this is departure time that it's storing. So the next person is coming, we have to check if his arrival time is greater or equal to the current departure time of the friend. Yes, then we will do the same thing here, and we will do this. If this is happening, then what we have to do? We will break it. Okay, same here. If we are assigning anything to the person, then we will break. We don't have to check for each chair coming next, right? And if nothing is happening, then we will return -1. Think, yes, we will try to run it. Yes, so let's just try to submit it. Yes, we have successfully submitted this question. So now this is why it is submitted, because the constraint, if you check, these are 10 is to power 4. As we have discussed, if it is 10 is to power 5, it should have given the time limit exceeded error. So now what we have to do? We have to optimize on this. So we will remove all this, and yeah, now what we have to do? We will have to create a priority queue. So priority queue, that will be of minimum heap type that we discussed. So it will be, first we have to occupied one. So pair, then vector of pair, okay, and greater int. So it will be greater of pair. Now this will be our occupied chairs. So let's just do, okay, now you can see it properly, occupied chairs, right? Similarly, what we have to do? We have to create another chair of integer type that will store the, okay, so that will store our current free chairs. So this will be greater int, okay, and its name will be free chairs. Again do the sorting, and we have to store the current chair number also here, current chair, that will be 0. Now what you have to do for each? Again same thing, arrival time, that will be times of I 0, and similarly arrival and departure time times I 1. Now the main thing comes, remove, what we have to do? Check for occupied chairs that will be free, Okay, so we will go for occupied chairs. But we have to check if occupied chairs are not empty currently, and this occupied chairs, this top, what it will contain the first chair that will be available earliest. Okay, so its time, so it will be first. It will store the, but it will store in this pair departure time with the chair value. Okay, so this departure time is less than and equal to current arrival time, right? If it is yes, then what we have to do, we have to remove it and add it in a free chair. So what we'll do, we will get the free chair value. Free chair will be this occupied chairs dot top dot second, and we will remove it occupied chairs dot pop, and this free chair is added in the this free chairs. So free chairs dot push this free chair, right? This is done. Now what we have to do, we have to, whenever we come out of this, all the chairs that are occupied and with the current arrival time, they will be free, they are added in this free chairs. So now we'll check if free chairs is empty. If it is empty, that there are no, that nothing we have removed. Okay, so now what will assign to him, now occupied chairs, this current chair will be assigned to him, right? So occupied chairs dot push, what will add the current departure time with the current chair. Okay, and at here only what we have to check, if the arrival time is equals to the target arrival time that we have, right? If it is yes, what do we have to return, the current chair? Yeah. Now if it is not, then we will update our current chair, right? And if you check, if free chairs are not empty, then the top free chair is assigned to this current person, because that is the smallest chair that is available to this current person. So now you will store smallest chair, and it will be free chairs dot top, right? And you will remove it from free chairs now, free chairs dot pop. Okay, now you just have to, first you can check directly the same thing that you have did above. If current arrival time is equals to target, then you will, what you will return, smallest chair. If it is not, then you will just add it in your occupied chairs with your departure time and smallest chair. Think yes, we are good on this approach. This is assigning free chair to ith friend. So I think we should make a habit of adding comments in our code to better understand. Okay, looks good, and it is understandable also. So let's just try to run it. Okay, so we are lacking, yeah, free chairs. So it will be free chairs. Okay, so it is smallest chair. Okay, so occupied chairs. So occupied, okay, occupied chairs dot push. Yeah, we are good on this. Let's just try to submit it. Yeah, we have submitted it successfully. Thanks everyone for watching. In case you do like this video, please do hit that subscribe button and like it. And in case you have missed anything, you can watch it on my YouTube channel. I've created a curated playlist for this Leetcode challenge as well as the 75 days challenge, where we are solving the 75 questions that are most important from the interview perspective. And you can also try this using a set thing, ordered set, which is in a like directly set in C++. Okay, you can try with set, so it will be a similar approach. Okay, the operations will be different similarly, and the time complexity will also be somewhere around equal to this priority queue. So yeah, thanks everyone.